Hey everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we're going to look at Lesson 6 from Chapter 7, which is looking at properties of systems of linear equations. So up until this point in our chapter, all of our equations have had only one solution. But when we solve a linear system in two variables, there's actually three different possibilities. And so there's three different situations that we can look at. So to determine the number of solutions a system has, we can compare the slope and the y-intercept. So our first situation, or our first possibility, is where we have one solution. And so here we would have one solution if the slopes are different. So here in this kind of situation, you only have to look at the slopes. So if the slopes are different, then it's one solution. So then what happens if the slopes are the same? Well, then at this point, there's two possibilities. So for our second situation, when we have parallel lines, and with this one here, there is zero solutions. And this one here is where you have the slopes are the same. But what's different about this one here is that the y-intercepts are different. So then in our last case, this one here is where we have an infinite number of solutions. And that's because these two lines are what we call coincidental lines, and that means that they overlap so that they're literally one on top of each other. And this typically happens, and don't think that this might just be a simple yes or no question when looking at these equations, but typically what happens is that one is in general form, maybe one is in slope-intercept form, and when you manipulate them all to be in the same form, then you'll notice that you get the exact same equation. So this is where the equations are exactly the same. So your slope and y-intercept are the same. So once again, there are three different possible situations that we can have when we have a system of linear equations. So the first one is when we have one solution, zero solutions, or an infinite number of solutions. So here we're going to look at examples 1a and b from your notes. So here we're going to determine the number of solutions of each linear system. So here our first system is x plus y is equal to 3, and negative 2x minus y is equal to negative 2. So in order to determine how many solutions a system has, you have to convert it all into the same type of equation. And my hint here is just, I would always put this into slope-intercept form, or into the form y is equal to mx plus b. That's the easiest way to convert an equation all into the same form, so we'll just stick with this one here. So in our first equation, we have x plus y is equal to 3. So here I want to get y by itself, so I'm going to subtract x on each side. So on the left side, we're left with just y. And then just to follow our slope-intercept form, I'm going to put x first. So you have negative x and then plus 3, since 3 is positive here. So my second equation, we have negative 2x minus y is equal to negative 2. So once again, I'm going to get y by itself. So here we have negative 2x. I'm going to add 2x. So I'm left with negative y. So don't forget that negative. So that's equal to 2x minus 2. Then I want just y, so I want to make that positive, so I'm going to divide each term by negative 1. So that basically just changes the symbols of each of your operations, of each of those terms. So here we have negative divided by negative makes a positive. 2x divided by negative 1 makes negative 2x. And negative 2 divided by negative 1 is positive 2. So our first step here is to figure out how many solutions our system could have. Step number one is to look at the slope. So here we have a slope of -1, and here we have a slope of -2. So as soon as you see that the slopes are not the same, this tells you that there's only one solution. So just to repeat, if the slopes are not the same, so if they're different, then there's only one solution to the system. So example B here, we have the equations 4x plus 6y is equal to -10, and -2x minus 3y is equal to 5. So once again, I'm going to put these into slope-intercept form. So here we have our first equation is 4x plus 6y is equal to -10. Once again, I'm going to solve for y, so I'm first going to move 4x over by subtracting it. So then we're left with 6y is equal to -4x minus 10. Then I'm going to divide by 6 to each term. And we can leave this as reduced fractions. So we have y is equal to -4x over 6 minus 10 over 6. And if I'm leaving it with fractions, what I want to make sure I'm careful with is I want to make sure these are all reduced fractions. That way I can easily see if my slopes are the same and if my y-intercepts are the same. So I can reduce this first fraction by a factor of 2 to get -2x over 3. And I can reduce our second fraction here by the same factor to get 5 over 3. So for my second equation here, I have -2x minus 3y is equal to 5. I'm going to start by moving that -2x to the other side by adding it. So I'm left with -3y is equal to 2x plus 5. Then I'm going to divide by the number that's attached to y, so I'm going to divide by -3 to each term. So on my left side, I'm left with just y. Then 2x divided by -3, we'll just leave that as our fraction. And same with this one here, we have +5 divided by -3. We can simplify that to just a negative or subtract 5 over 3. So then what we're going to do is then we're going to compare the slopes. So you look here, we have our slope here is -2 over 3, and here our slope is -2 over 3. So these ones here have the same slopes. So then to figure out if they're parallel lines or coincident lines, we need to look at those y-intercepts. So here your y-intercept is -5 over 3, and here your y-intercept is -5 over 3. So those are the same as well. So that tells you that these are coincidental lines, which therefore we have an infinite number of solutions. All right, so just as a quick recap, remember we can determine the number of solutions that a system could have, and there's 3 different possibilities. So you have one solution where your slopes are different. You could have parallel lines where the slopes are the same, but your y-intercepts are different. And then we can have coincidental lines where both your y-intercept and the slope are the same, which gives you an infinite number of solutions. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. Thank you guys so much for watching.